This is Joe Heinz, and I'm the owner and CEO of Voice and Data Networks. I want to thank everyone for attending our SIP seminar today. And I know that SIP is a new and intriguing and kind of a hot topic in our industry, and we've gotten lots and lots of response on this particular webinar. So thanks for joining us, and I hope it's enlightening. The reason Voice and Data does this is Voice and Data has a mission statement that says that we make communications applications return profitability and efficiencies to our clients. And I hope this presentation gives you some ideas on how to obtain some of that profitability or some of that efficiency for your organizations. In an effort to continue to engage you or any of your colleagues in future educational opportunities at the end of the seminar, if you'd like to, a question will come up asking you what other topics you might like to see regarding communications, be it SIP or again, because we could certainly talk about it 5 or 6 different ways, or something else like call recording. Please jot those things down and answer that question about what you'd like to see in the future, and Voice and Data will be gladly bring it to you. So I thank you again for joining us this morning, or this afternoon, I guess. And I'm going to hand this over to our trusted colleague and a systems engineer at Avaya, Michael Vance. Michael?
Thanks, Joe. So I'm going to get my presentation launched here. All right. When Joe asked me to do a presentation on SIP and how it would be implemented, for Avaya, that's a very easy question to answer. For the industry as a whole, it might be a little bit different. So I'm trying to give you a sense of what the direction is of SIP, why we're going in this direction, and what the payoffs are going to be for enterprises that kind of get on board. We'll start with just a brief look at how things used to be. One of the advantages that we're going to get from SIP really comes about as a result of decoupling of the application layer from the connection and the access. We saw a transition in this earlier on when IP telephony was first introduced. We went from the monolithic PBX environment on the left, where everything resided in the single cabinet or multiple cabinets, but a single instance of an operating system, to an area where we could remotely place gateways and decouple the access layer from the brains or the central operation. Now what we're seeing is a next generation where the applications themselves as entities are going to be separated from the call processing or the connection management. And that's really what you see on the right-hand side. As we move to a SIP-based architecture, and let me make a point here, SIP is not an architecture, SIP is a protocol. There are architectures built on that protocol, Avaya Aura being one of those architectures. So a SIP-based architecture gives us some inherent advantages when it comes to the comparison between that architecture and some other methods of doing the same type of thing. One of the biggest points is the ability to put centralized management into the equation. When we talk about centralized management, it's no longer just the core telephony applications that we want to be able to manage separately. It's really every aspect of the user experience. It's the applications that the end user is going to use in a daily environment and tracking to make sure that those applications are available and performing up to the service level agreements we have. But it's also application delivery, which comes about as a result of being able to manage the infrastructure that's carrying that application. And I speak of applications, I'm also including voice and video as an application on my network. So when I start to talk about a real-time environment, the next thing that becomes mandatory is to have an always-on type of network environment. And we could accomplish that with redundancy in hardware, and we could accomplish that with resiliency. And the main aspect in terms of resiliency is that I can utilize the infrastructure and the design of the infrastructure to provide multiple pathways for the delivery of the application. That means that I can fail over from one data center to another data center without impacting the end users. And that's one of the main keys in terms of the SIP-based architecture. We're going from an idea where the applications were built at the core and delivered more or less equally to everyone, a la a PBX environment. And sure, my buttons on my phone might do different things than the buttons on your phone, or I might have a phone with fewer buttons than someone like Joe might have. But as a result, the end user experience and the application that delivered were all bound by the PBX. Now, as we create an environment where various applications can reside at the core and then be delivered as needed to the end user, what we see is that the end user becomes more important. So we talk about scale and the ability to support a number of end users. That also means that we will be delivering unique sets of applications to each end user. So although from an administrative standpoint, I may group end users into a template so that I can create multiple end users at the same time, ultimately I'm going to be delivering the applications that are specific to that user. And that also comes into play when we start to talk about mobility, because end users who have a set of features available to them want to have that same set of features no matter where they are within my enterprise. This also means that if I have a failure of equipment in my enterprise, that I still need to be able to deliver those same features to that user. Think of it in terms of a cell phone. Wherever I go, even if I'm roaming on someone else's network, I have the same feature set available to me. That is the core of what we're building with SIP. And it kind of makes sense because the cellular network was built on the same 3GPP standards that are being implemented across an enterprise SIP deployment. Anytime you make a change within your organization, you're looking at enhancing or bringing back for the communities within your organization. What I'm going to talk about here are really three areas or spheres of influence within an enterprise that are going to see a benefit from implementation of a SIP architecture. First off is the end users. End users can come in many different shapes and sizes, but almost all of them will have a desire to communicate in a specific manner. For some people, their chosen form of communication is text. For some people, their chosen form is email or speech. Not only are they going to choose a separate method of communication, but they want some flexibility in terms of the device that they use. Some people prefer a BlackBerry. Some people prefer an iPhone. Some people prefer a desk phone. Some people want to have a soft phone-based application on a PC. Each one of these users will, by necessity, have a distinct user profile that will bring the communications necessary to them across whatever device they've chosen. And those communications can also begin to tie into external communication methods such as a social networking site or across entities or corporations where I may choose to allow some of my people to have a direct link to people at one of my top vendors or suppliers, or work some type of IP or SIP peering between my organization and an outsourcer. The main focus in moving to a SIP architecture is that we begin to put more and more emphasis on user centricity. It becomes more about the user. When we talk about being able to impact the business itself, we move into a discussion kind of around the individual lines of business. What are the things that each major part of my organization desire to accomplish? If it's sales, are we looking to enhance our communication with our customers? Are we looking to have an opportunity to bring the ideas that we have in development out to our customers at a more rapid point? Are there things that we can do within the organization of IT that will enable the lines of business to create ideas and move them into production faster? And one of the things that we gain by utilizing a SIP architecture is the ability to lessen the time it takes to prototype an application and deploy it. A part of this comes about as a result of utilizing a standards-based architecture in order to have the interconnection between the various little pieces of an application, or centralized applications and a communication application that wants to talk to it. But another part of this really comes about as a result of being able to prototype and deploy almost into a production environment. And I'll talk about that a little bit when we talk about sequenced applications. But the advantage is that I can build an application and deploy it to a subset of users, leveraging my production infrastructure without having to prototype specifically in a lab. Once I feel the application is fairly solid, I can begin to deploy it out on the production environment to end users. And that brings us to the IT organization. There's two areas within IT that are at the forefront of a decision to move to a SIP architecture. First is that you have an opportunity to be a leader in IT rather than reacting to the requests from line of business. Once a SIP architecture is adopted by an IT organization, they can now begin to go out and look for what I call targets of opportunity within the line of business and bring to those lines of business applications and functionality that that line of business may not even realize that they were going to benefit from. It allows an IT organization to begin to become the heroes in developing and prototyping and bringing things along for the line of business if you work at an organization where the lines of business themselves are a little bit hesitant to change. And the main part of that is that I'm able to bring along an application at a lower price point with less risk so that I can begin bringing up ideas in front of the lines of business and showing it to them without having to invest an awful lot on the back-end systems to make this work. It makes things like complex interactions that we used to rely on CTI for much easier to bring to fruition. And of course, the second part of this is that IT organizations are looking to lower their costs. It's incumbent upon all of us within organizations at this time to try and reduce waste wherever we can. And IT is no different. Certainly we all pine for the days when IT's budget seemed to be virtually unlimited and we could buy all the toys we want. But now the reality is much different. If we want to have new technology, if we want to have things in our environment that we feel are the future, we're going to have to do it somehow by showing that there's a cost savings or some type of other tangible benefit that we can bring about. Reducing operating expenses is one area that SIP architecture has some advantages in. Most everyone has been approached at one time or another by a carrier offering to bring in SIP trunking. A SIP trunking oven by itself doesn't necessarily lower a cost. However, an opportunity to aggregate trunking from disparate sites into one central location while still being able to meet a service level necessity for delivering those calls to the remote locations can bring about a certain amount of cost benefit. Also, the concept of tail-end hop-off has been around for a while, but a SIP architecture allows for that to be much easier because the routing that I'm going to be using to determine the best route for a call now resides in my SIP routing engine rather than residing in a bunch of separate PBXs. And I'll show you how that works here in a minute. But the main thing is that when we look at the things that an IT organization will use as decision makers, reducing operating expenses is one half of the equation. There's other opportunities for cost savings that have to really be examined a little bit and searched for. One of the biggest ones that I've run across recently is in the mergers and acquisitions area. In the past, even if an organization did due diligence to try and figure out what it was going to take to bring someone they acquired into the fold and provide them with the same level of application services and communication services that the rest of the enterprise enjoyed, it was an awful lot of work. In some instances, we had to completely rip out existing infrastructure to replace it with my company's standards in order to get them into compliance. If I build a SIP-based architecture, such as Avaya Aura, I have an opportunity to bring those disparate systems into my environment and make them connected to my architecture, much lower price point and much easier, while still being able to deliver the applications that are necessary. So when an IT organization looks to invest in a SIP-based architecture, one of the things that can be brought out is that there are certain benefits of having that architecture that will apply against a couple of different areas. Integration with outsourcers is another one. If your organization uses outsourcers in a manner where communication could come into your organization, flow to the outsourcer, and then possibly come back to your organization for some wrap-up, you'll find that a SIP-based architecture enables that much easier. So the cost savings that are out there are direct cost savings that are easily identifiable and tangible, and then some additional savings opportunities that really need to be uncovered. So now we'll pause for a poll question. So as we bring disparate systems, as we look at an organization that's maybe going through some acquisitions, or an organization that over the years has built individual areas based on the needs of that particular location, you'll find that you often have multiple disparate systems within your organization. This example, PBXs with standalone voicemails that have traditionally operated autonomously. Now, they may very well be connected through some type of PSTN-based network, and we might have worked very, very hard to build a cohesive dial plan for all of those locations. But for the most part, each one was its own individual touch point in terms of management and also in terms of the feature set that was available to the end users. A couple of the locations maybe we had built into a multimedia conferencing. In order to make them a participant in a SIP-based architecture, for some of the locations, all we have to do is an upgrade of the existing infrastructure at that location. For a few others, maybe we'll place a small, inexpensive gateway in order to be middleware between the existing PBX environment and this architecture. This is when we bring in the Avaya Aura architecture and bring in Aura and Session Manager. Are able to talk back to and flow information back and forth through this core. The core now begins to handle my routing information between each of these locations. These locations now only have to know about themselves and the core. They no longer need to have any knowledge of the other locations. And this aids tremendously when I'm bringing in additional locations into this environment. Now that I have the core, I can begin to move certain services from the edge or being connected directly to the PBX and move them up so now they're directly connected to the core. At this point, I have begun to standardize not only the user experience across my various locations, but now certain features and functionality are identical all the way across. When I bring in the next level, which is communication services, now I have an opportunity to deliver the communication application and that feature set to any of the locations that are connected into my enterprise, but also to some devices themselves. This is where I begin to make the transition to that user centricity. This is where I have an opportunity to define my user experience that I desire and then feed a specific user experience to specific users. So regardless of the hardware platform of which they used to be a member, now I can begin to give them applications and feature sets at a specific location on the device of their choice, regardless of what was there previously. There's no need to rip out the equipment that was already in place. I have now the ability to layer on, by using a SIP-based architecture, additional feature and functionality, and bring most of this into a centralized core for management purposes. And once we start talking about SIP-based and make a transition from the traditional TDM type of architecture over to a SIP-based, we also recognize that every single interaction is no longer dependent upon the functionality that's at that specific location. So I can begin to build video services at the core, which then the individual endpoints or the individual users can take advantage of. So by architecting it into the core and connecting each individual location into that core, I have the opportunity to build in a network that allows me to go from a phone call to a text chat to a video session seamlessly, simply by changing the media stream while keeping a standards-based SIP signaling protocol to control the calls and to control the flow. Once I have the basic functionality built in across my network, then I can begin to add in the SIP trunking and the centralization of the SIP. I can also begin to build tail-end hop-off, and my coordination for dial plan becomes much easier because the Avaya Aura Session Manager at the core begins to be my routing engine, and it can work towards building a cohesive dial plan across all of the locations. I also have the potential now for voice over IP peering. Peering is a relatively new concept, but the idea would be that I can now peer my organization's network and infrastructure to someone else's organization and infrastructure. One of the biggest users of this is most likely going to be in the outsourcing industry, because by creating a peer relationship, I can begin to pass presence information. I can begin to allow media streams to flow more freely between my organization and my peered organization. And Avaya does this by using adaptation modules inside Session Manager. These adaptation modules are built in such a manner that they can be added or subtracted without any kind of impact to the overall architecture or any kind of downtime. But it allows Avaya's architecture to latch onto and peer with any other architecture, even if, although SIP's a standard, they may speak a different dialect. So the adaptation module does the translation necessary for an Avaya or a SIP architecture to be able to speak to another SIP entity that may not speak exactly the same dialect of SIP. Okay. The custom applications. And at this point, we're really transitioning from the delivery of the standard telecommunications type of applications and moving into a realm where we are linking the telecommunications infrastructure directly to the business applications infrastructure. And there's a lot of work that's been done in the past to try to build bridges between these two. Most of it has been done through what we all would have called computer telephony interfaces, or CTI. And CTI could be very complex and required an awful lot of middleware because each PBX vendor would have spoken a different version or a different type of CTI language to the middleware, and then the middleware had to parse that again in order to talk to the business application. By building on a SIP, SOAP, SOA standards-based infrastructure, we have an opportunity now to bring that to the core and develop the applications directly from the core environment. So Avaya Agile Communications environment becomes an entity that resides at the core, has knowledge of all of the access layer or endpoint and end users, and can speak a standards-based language and protocol to deal directly with the business applications. I believe now we're moving to another poll question. So I'll bring up the concept of sequenced applications. Sequenced applications are applications that are allowed to insinuate themselves at various aspects of the communication flow. And I'll give a couple of really good examples later, but the main thing to think about when you talk about sequenced applications is that it allows each communication to go through certain gates or checkpoints and then be acted upon based on a set of rules or business standards that would apply to that specific conversation or that specific interaction. And they have some advantages in terms of how we would treat a sequenced application rather than how we would work in a regular CTI environment. Sequenced applications are designed to be smaller, more directed, an application that really does maybe only one or two things, that resides on a server, and multiple users can have access to that application based again on their user profile, bringing back that user centricity. But the application itself is easier to develop and can be altered or changed kind of on the fly. You don't have to take the system down in order to make a different version of the application or in order to add an application into the sequence. And I'll go through how that works. But the biggest thing that we benefit from in this environment is that now we can begin to use standards-based languages and standards-based APIs to build these applications. So a small application that may be developed by your own organization or by an Avaya business partner, such as VDN, or through a third-party developer, consultant, DevConnect partner, all of those applications will be available to your enterprise. You'll be able to choose best of breed, but you'll also be able to solve specific business problems that maybe only your organization faces by developing an application in-house to do a specific task for you. So once these applications are developed, we have an opportunity to rapidly deploy them. Changing a user's sequence is as easy as adding that application into their user profile. I can apply a template in the management platform to allow that application to apply to all users who fit inside a certain template. So I can deploy it to large scale of an organization very easily. But in the prototype and testing phase, I can choose individual users and add that application into their user profile without worrying about a disruption that it's going to have into the rest of my organization. A little bit about a difference between named applications and sequenced applications. Some applications will be a landing spot. There'll be a place where the call or the communication tends to terminate, and then if additional work is done, that application will forward it on and push it through, but it'll be treated a little bit differently. In a sequenced application, the application sees what happens at the instant of time, and then it moves through. It's released by that application and moves to the next application in the sequence. But a named application would be one where I am sending a user or an external call or an internal call or some other method of communication to this application with the expectation that I don't have to do anything more with it from the core, from the SIP routing engine, until that application hands back to me for some reason. Some examples of centralized applications that fall under the named applications would be the modular messaging or meeting exchange, modular messaging being voicemail, meeting exchange being a conferencing, web conferencing, or voice portal, which is the IVR application. These will interact directly via SIP to the core, be available to all of the access layers out in the rest of the organization, but they become applications that are the end point for transactions. Once a call goes into modular messaging, it may terminate there without any more work on the part of the core. So in order to really understand sequenced applications, you have to hear about the half-call model. In traditional PBX environments, the call, both ends of it, both the caller and the callee, or the origination and the termination, were handled by the PBX for the most part simultaneously. There were a few features that an end user could invoke that would require the PBX to handle a call in a certain way, such as a call forwarding button or a do not disturb button being pressed on an end user's phone. But for the most part, the PBX treated the call as a single flow of information from point A to point B and made the routing decisions within the communication engine of the PBX. The half-call model changes this a little bit. If Session Manager becomes the routing engine within this architecture, it can treat the origination of the call completely separate from the termination of the call. So in this particular example, if user 1 is going off hook to call user 2, the SIP invitation is sent through Session Manager, who determines what feature server this user has, and in this case it's Communication Manager, and passes that call off to Communication Manager, where Communication Manager has an opportunity to say, yes, this user is allowed to make this call. This user has these particular class of service, class of restriction, and I will now pass that call back to Session Manager so Session Manager can continue to send that call where it needs to go. So we've finished with the origination side of the half call model. Now Session Manager begins to deal with the termination side of the half call model. It identifies who the call is destined for, and it forwards that request up to the routing engine part, which forwards it to the feature server that would be responsible for user 2. In this example, both user 1 and user 2 are using the same feature server, but the SIP messages go up to that instance of Communication Manager, where Communication Manager now looks at an incoming call to user number 2 and determines what to do with it. If user number 2 had Do Not Disturb set on their phone as a feature being enacted, then Communication Manager would send that information back to Session Manager, who would then forward it off to user number 1 to handle the call correctly. So Session Manager now treats the termination side through the feature server and finally gets it to the end user. Now keep in mind that this is using SIP as the protocol for signaling, regardless of what the media stream is that flows between user 1 and user 2. So in this particular diagram, we're talking about a voice call from user 1 to user 2, but it could just as easily be 2 video endpoints that we're going to connect, and the media itself, the audio stream or the video stream, would flow directly between the 2 endpoints. So SIP is utilized as the command and control protocol and is treated in this half call model, but the media flow is still direct from user to user. So a sequenced application is an application that I can insert into this call flow. Session Manager is the routing engine that determines, by looking at the user profile, which sequenced applications the call needs to go through based on that user's profile. So in this instance, user number 1 doesn't have any sequenced applications when they are originating a call. So the command language goes directly to Session Manager. Session Manager has an opportunity to determine which feature server that user resides on and passes the request up to Communication Manager. Communication Manager handles the origination side of that call and passes it back to Session Manager. Now Session Manager works on the other side of the half call model, or the termination side. That call is sent back to the feature server for user number 2, which in this case happens to be the same instance of Communication Manager, where it's determined that the end user does not have any application turned on in Communication Manager that would prohibit the call coming through. So it passes that request back to Session Manager. Session Manager now recognizes that this user has an application in sequence. And this application, for purposes of this discussion, is a call filtering application. So it passes the request to the call filtering application. This application is very simple. I have a web interface that allows me to choose specific telephone numbers that I want to receive calls from, or specific users that I want to receive calls from, and maybe users that I don't want to receive calls from, or users that will be treated with some type of high priority. I might also have time of day routing built into this application. So for an example, my boss can call me anytime they want to, but I may restrict coworkers from calling me during my lunch hour. So that the application now has the information that a call is coming in for user 2. It compares it against what it's supposed to do, the rules that are built, and how that application is configured for that specific user, and then makes a determination as to what to do with that. For an example, that application may be told that when certain criteria are met, to send the call directly to voicemail for user number 2. It may also send the call to some other endpoint or some other SIP entity, such as a voice portal or an announcement board, where a certain message is played and then the call is terminated. So I have an opportunity now to build an application and have it run in sequence. Ultimately, if it's my boss calling me as user number 1, the call filtering application will see who it is that's calling, recognize that that call should go through, pass that back to Session Manager without altering it, and then the call comes to me. And then after the call setup and the command and control signaling is done, the media would flow directly from endpoint to endpoint. Now, it's important to understand that sequenced applications can be layered upon each other and built into not just the termination side, but also onto the origination side. So in this example, user 1 is going to make a call. And for purposes of discussion, we'll talk about this in terms of user 1 being an internal call and user 2 being an external person. So let's say user 1 is an attorney. Now, typically, when a law firm has an opportunity to collect information about the time that an attorney spends on a customer or client and capture that, they can turn that into billable hours. So I've built sequenced applications that allow me to automate that process so that the end user is not burdened with keeping track of that. I've built it into sequenced applications. So my attorney goes off hook and he begins to make a telephone call to one of his clients. That request is passed on to the call billing with the expressed intent of having that application determine whether or not billing information should be recorded on this call. So the call billing application holds a list of all of the clients that we would talk to, all of the open cases that we're working, and would create a billing entry as that call was passed through. So the call billing application starts the call billing. It passes it back to Session Manager, which then sends it to a call recording app, because we've determined that in order to give the best customer service to our client base, certain calls with certain or all calls with certain clients need to be recorded. So now we apply the call recording rules that we built and make a determination for this call whether or not it should be recorded. So we've determined that yes, we do want to capture billing, and yes, for this specific client, we do want to invoke call recording. So both of those applications have done their work. Session Manager now sends that request to the feature server of user number 1. Now, part of the sequence here is that once that request comes back from CM to Session Manager, we may be done with the origination side of the half call model. In some terms, various applications, in this case context tagging, may be treated on both the origination and then sent again on the termination side, depending on what's happening. So now Communication Manager has forwarded that off to Session Manager with the determination that, yes, here is an outgoing call. Session Manager now feeds that back through a sequence of applications before getting to the out call to the client. One of these may be a call filtering application. Now what we may be doing is checking a list that we have prepared, or a set of business rules to try and maintain customer satisfaction. So let's say, for an example, a specific client has told us that they really don't want to be called by the law firm between 3 o'clock and 4:30 in the afternoon. But rather than going to each one of the attorneys and letting them know about these rules, we simply enforce those rules in the call filtering application. So as a user, I've made my call. Now I hit the call filtering application, and that application may deny the call based on the set of rules. It may also deny the call based on who I am. So certain clients may have expressed a desire to only talk to senior attorneys and not to any of the junior attorneys. Therefore, they can build those rules into call filtering. I have other applications that I can put this call through before I finally send it off to the end user. Context tagging is a relatively new idea. You'll see a product announcement from Avaya coming fairly soon that allows us to have a conference call that's being recorded, but add tagging to that recording in a textual format so that I could have a conversation with my client, and at a certain point in the conversation insert text that says, this is the point where we talked about this particular point of interest. This is where we talked about this. Or here are some notes that I took while listening to this person. So context tagging becomes an application that I can invoke and a functionality that I can add to a conferencing environment that will allow the retrieval and the dissection of that call to be considerably faster. So you can see that there's sequenced applications that are going through the environment, and each end user can have access to specific applications on the way by. Now, it's a very complex looking environment, but it's very simple for an organization to implement, because when we do this, we understand that we're moving into a half-call model, which allows us to dissect the call into those two parts, treat the origination differently than we would treat the termination of the call. But each one of those applications can be applied against either termination or origination based on the rules in the user profile. We have the ability to move these applications into the core, rapidly develop those applications so that when we have a business problem that presents itself or a business need, we can bring to bear in a relatively short period of time a new application designed to specifically solve that. Now, the idea of developing applications is fairly straightforward in most IT organizations, but the ability to determine which applications you need or what might work in your environment is unique to each organization. And this is a point where you may want to bring in outside expertise, such as voice and data or telecommunications consultants, to analyze your business practices and begin to develop sequenced application flows that will enable your organization to prosper. It's very important that you begin to focus on what's possible, what the opportunities are, and then allow a little bit more free thinking so that you can recognize how this might be utilized within your organization. So, got another poll question here, I believe. So you can see that the SIP architecture is much easier to move into than some of the previous telecommunications architectures that are built in the past. The advantages of being able to bring in access layers that are from disparate systems, or to simply drop endpoints in locations that tie back to the core, make it a very easy architecture to expand out and to hook into. But the results, once you have the access layer determined and you started to build out the core, the results that are available are very powerful. Having an opportunity to have a centralized application such as System Manager that will take care of the core, manage my user profiles, and keep track of the routing necessary for all of those access layer elements to be able to talk to each other, makes building into this type of architecture leverage out the reduced cost in maintenance and management that I would expect from having a monolithic type of environment, as we saw before when we were doing flatten, consolidate, and extend. But the ability to bring in the SIP-based applications and deploy them in a manner that allows all of my users to take advantage of the applications that will impact them on a daily basis is really where this type of architecture has its most benefit. Within your organization, you can look at the types of communication, the types of end-user applications or end-user elements that I need to be able to support, and I can look externally to the type of customer service that I want to be able to give in the future, and how I can meld those together utilizing a standards-based architecture that allows me to plug in various applications and put them into the flow of my conversation or the flow of my communication in a correct order without having to have a negative impact on the rest of the organization. If we take a simple example of a contact center environment and we apply the architecture of Aura at a SIP level, what we see is the ability to bring to the agent better information as a result of utilizing sequenced applications that may gather information about the caller or about other elements of the caller's interaction with our company. For an example, if I have an architecture built that can allow me to pass information about web services back and forth, I now have the ability to go talk to a web server and recognize what sites that person who's on the phone with me today has had contact with. So I can do assisted browsing or directed browsing or historical understanding of the interaction that I have. And then as that interaction progresses through my organization, that information can continue to go with it as that user is directed within my organization. So for a contact center, the desire of having better interaction with my customers and better flow of information can be realized by an application of a SIP-based architecture. And if I was going to leave you with one final point, and the main thing that probably architecture of this type is going to hinge on, is that we've moved from the idea of providing a universal type of level service to everyone to an era where individual users can be treated uniquely, and we have an opportunity now as the providers of application and as the providers of service to personalize to the individual user the applications that they need in order to become more productive, and also separate them from feeling being tied to specific devices or specific locations. We've enabled our enterprise to branch out and grow and meet the needs of our users in a cost-effective manner. So Patty, I'll turn it back to you.
Okay, thanks for joining us, folks. If you have any questions, either about this SIP or any other contact, please contact your account executive or feel free to call me. We'll put you in touch with someone at 952-229-1154, or you can call our toll-free number 800-246-7999, extension 1154. Does anyone have any questions at this time? If you want to raise your hand via the GoToMeeting, we'll go ahead and unmute you if you have a question. Okay, Michael, it appears there aren't any questions at this time. Again, there will be a survey at the close of the webinar that would appreciate any feedback. Thanks again for joining us.